Today I'm here to explain a couple more problems for the end of the semester assessment for IB Math Studies for Part 3. So the first problem tells us that Pierre invests 5,000 euros in a fixed deposit that pays a nominal annual interest rate of 4.5 compounded monthly for 7 years. So what we can extract from this problem is that he invested 5,000 euros, that he pays an annual interest rate of 4.5%, that is compounded monthly, and that it was for 7 years. So what I did this was, so they asked us to calculate the value of Pierre's investment at the end of this time, so to give our answer correct to 2 decimal places. So what I did at this point was use a formula for compound interest, and I basically just plugged in the values. So FV would be the future value, PV is the present value, R is the annual rate of interest, which is given in percent form, K is the number of compounding periods per year, and we once again raised that to K, which is the same number, times the number of years. So as you can see, I did this here, and for example, K would be 12 because it is compounded monthly, and there are 12 months in a year. And so I'll also have to plug this the same way for the second problem, so I'll just, to save a little time, show you how I do these problems once with this one. So what I basically do to avoid getting confused, even though it's a little less practical, is I start out with this area here. So I just plug in 1 plus 4.5, oops, sorry, I forgot the parentheses, 4.5 divided by, 1,200, close parentheses. So I already did this in my head, 100 times 12, I know that it's 1,200, so I just press enter and I get this value. So now I have to raise this to this, which 12 times 7 is 84, so I'll raise it to the 84th power, get my new answer, and then I'll multiply this, finally, by 5,000. So I press 5,000, and this is the answer that I get. As you can see, the same one as here. And so for the next problem, it tells us that Carla has $7,000 to invest in a fixed deposit, which is compounded annually. So she aims to double her money after 10 years. So what we can do here is the same thing as the top. We just have to solve for the minimum annual interest rate now. And so we replace FV. We know that the future value would be 14,000 because she wants to double her amount, and we started off with 7,000. And the present is 7,000. So what I did here was I just divided by 7,000, and which would be 14,000 divided by 7,000 is 2,000. So I end up with having an equal of 2,000, which equals 1 plus R, the same thing that we did here. And we, since it is compounded annually, we just replace K with a 1, and the exponent would be 10 times 1, so it wouldn't change, it would just stay as 10. And so to solve this here, I just square rooted everything from this part with the 10th power, and so I just did the square root of 10 of 2,000 equals, to leave these alone. So I just plugged this into my calculator the same way I did this one, and it ended up being of 7.18. So the minimum annual interest rate is 7.18%. So number 2 tells us to consider the function f of x equals negative x to the 4th power plus ax squared plus 5, where a is a constant. So it tells us to write down the y-intercept of the graph. So in order to find the y-intercept, what I did was that I know that x will have to equal 0 in order for me to find the y-intercept, to find which value crosses the y-axis. So what I did here was just replace x for 0, and so I just got 0 to the 4th power is 0, anything times 0 is 0, and then plus 5. So I know that f of 0 is 5, so y equals 5. Then they tell us to find the derivative of f of x. And so what I did here was follow the basic rules for derivatives. And so you just have to bring down the 4 and subtract the exponent minus 1. So 4 minus 1 was 3. So I brought down the 4 and x cubed. And then plus, I did the same thing here, sorry. I brought down the 2, and it would be 2 minus 1, which is 1, which basically doesn't change anything. So I just have to write down 2ax plus 5, which this becomes 0 according to our rules. So it would just stay 0, and in order to simplify, it would be negative 4x cubed plus 2ax. So moving on to the second part, it tells us that it is known that at the point where x equals 2, the tangent to the graph of y equals f of x is horizontal. So show that a equals 8. So what I did here was that it tells us that x equals 2 at this point. So I just replaced the x with a 2, and I basically solved the basic equation like this, but left the a as variable in order to find the value of a. And I know that it would be 0, the y value here would be 0, and so I just replaced and solved, and it gave me that a equals x, which I was able to show and confirm what the problem was saying. So this way I know that it was correct. Then it tells us to find f of 2. So in order to find f of 2, we just have to replace the x given here by 2. So I just said, instead of negative x to the 4th power, I just said negative 2 to the 4th power plus a2 like this. And so I just solved by using exponents. For example, as I know that would be 4 times 8, and just respected those rules and got that f of 2 equals 21. So then they tell us that there are 2 other points on the graph of y equals f of x at which the tangent is horizontal. So it tells us to write down the x coordinates of these 2 points. So what I did here was that I saw here in the graph and I tried to find the x coordinates of these 2 points. So I also used my calculator. I think I have it here already. I already have it shown here. And so I used my calculator to find the values of that. It would be negative, since we already know that one of the points where it is horizontal is 2, then I immediately knew that one of them would be negative 2, because it's at the same point. The graph is constant with the other side. And then I also knew that it would also be horizontal at x equals 0, because this is when, for example, I know that I see it is horizontal, which confirms the statement told before. So then it tells me that the intervals where the gradient of the graph of y equals f of x is positive. So I just again looked at my graph, and I saw that it was positive. The gradient was positive when it was from negative infinity to negative 2, which stops here. And then here we see a decrease. Here the gradient of the graph is not positive, so I just did not include that. So I just did negative infinity, comma negative 2, and then union, since we're skipping this part, 0, where the gradient starts getting positive again, to positive 2. And then it stops again because it starts decreasing. So we basically just focus on these parts of the graph. And so this is what I showed here. As you can see, negative infinity to negative 2, union 0 plus 2. And finally, it tells us to write down the range of f of x. So the range is, I think that it was just from negative infinity to positive infinity, because since we start here and we include all the values, this is all the range of the graph. And so I just did negative infinity to positive infinity, because this graph goes on. And that's it. Thank you.